Hey everyone! So today I'm going to be doing a virtual contest, and I believe some other people from my Discord are joining me, so they're also going to be virtually participating. We'll be starting in a couple minutes. So let me just set up the virtual. And yeah, so I guess while I'm doing the virtual contest, I'll probably be explaining things a little bit less than usual. But that means, of course, if you participate, it means you can't watch live because, you'd be participating. Um, Cool. So yeah, I'm just setting up a couple logistical things, registering for the contest. Um, just to check before I get started, my video and audio is okay, right? Um, just scrolling up a little. Cool. I will post a edit command link. Okay, awesome. Okay, cool. And I'll register for the virtual now. Oh, whoops. Okay. Better log in. I guess I'll do 11:22, so we'll start in 2 minutes. Cool. Yeah, so I probably won't be talking as much as usual, but I'll try to thanks. Cool. So I guess I will try to set up my environment. And my layout might not be as good for spectators as it usually is. I might not show the problem, so you might have to look at the problem via typing a link in the chat. And as always, you can join my Discord or see if you can beat Neil. How did Neil do? I'm guessing he solved everything and got first. I'm using Windows, and then I'm using WSL to use Ubuntu on Windows. Cool. Yeah, I have multiple monitors, so I'll probably be putting some stuff on the other monitor, but I'll try to keep all my code on this monitor at least. Like the only Div4 ever? Yeah, I think I did it. um, and then I think some user was making unofficial Div4s, and I haven't done any of those. All right, let's get started. Guess I can start reading the problems. Okay, so guess multitest. So whoops. So if A is greater than B, we want to subtract something from A. So if we have an even number, then we can do it in one step. Otherwise, it'll take us 2 steps. And then this one should be the opposite. Cool. So submitting. Okay, so you can do some of the adjacent pairs. And oh, we just print yes or no. Okay, awesome. So for here, it seems like there are just some like blocks that you can sort. So let's read the input. So what do we want to do here? We want to take like adjacent blocks and kind of split the array on those. And the array could have duplicates as well. Oh, the constraints are quite small. Okay. So Okay, so now this looks right. Alright, this is a pretty tricky one implementation-wise. I wonder if I could have done it cleaner. Oh, and this is wrong. Okay. Oh, I need to subtract 1 from all of these. That's a classic. Okay. Alright, let's submit this. Hopefully this is right. Cool, so this is a problem that someone in chat said that they liked. So we just... What? Okay, so they're saying that you take all these prefixes, I guess? Note that at this point, you will not perform the combo because of the mistake. What? Okay, so it seems like we have to just take all these kind of prefixes and like figure out how to add them up. This seems somewhat straightforward. Wait, what? The number of tries. Oh, I see, okay. And and I guess this is all big enough that we can't... Okay, cool. So I'll sort P in reverse. Oh, I'll sort P forward, I guess, and then... Okay, let's see if this is right. Cool. All right, I'll submit this. Hopefully I don't get over. Okay, nice. All right, 3 integers. You can add plus or minus 1 to any integer. Okay. But you have to keep them positive. And you want to make A divide B divide C. Wow, okay, that's interesting. It's actually very weird. Yeah, my first thought is this seems kind of like a gross problem, but I don't know. I can't really. I'll try to think about this a little more. So you can make them all the same. All right, that's fine. I guess if you can bound how much you can move each of them, then that's good. But there are 100 test cases. Okay, so I guess we could try every value of A, and then for that, we can find the minimum. Wait, that doesn't even work. Maybe we try every value of B. Yeah, and then once you fix B, you can try to easily compute the answer for C and A. And then for B, you have... I mean, you can always turn everything into 1, so you can probably bound B between, like... Or you can turn everything into C. Yeah, okay. So you can bound B between, like, 1 and, like, 2 times 10 to the 4th for sure. So let's try implementing that. Oh, I don't actually know what const expr does. Is it better than const? I'll have to learn about that after the contest, I guess. But I mean, by doing const, I'm already, writing cleaner code than 90% of competitive programmers. But I definitely do need to learn about const expr, it seems. I guess I can just find the factors without a sieve. Okay. So int cost equals 0. No, I don't actually use C++ at work. Alright, something's up. Hmm. Ah, right. Oh, I need to print the actual values? Oh, man. Okay. Oh, and my answers are wrong anyway. Wait, why is this wrong? Hmm. Nice. Oh, and I don't want to add up all of these costs. I want to just take the minimum of them. Maybe this. Okay, cool. Oh, this is actually kind of annoying. I guess that should be an X. Alright, let's do this a new way. Okay, cool. That was definitely a bit messy, but I think, I don't know, I think it ended up like okay. Cool. Yeah, it's kind of slow. I guess this factoring. Um, cool. We need to construct a tree with the sum of depths equal to something. Okay, this is a definition of binary tree, I think. Okay, and this isn't too big. So why is this in braces? It's kind of weird. Okay, so okay, I'm thinking that, oh no, it needs to have a certain number of vertices. Okay. At first I was thinking you would be able to like make a line, like I guess I should probably start drawing for this problem, both for the viewers and so that I know what I'm doing. Yeah, this E looks pretty tough. Okay, so my initial idea was that you can just make a line, and then when you get to the bottom, then what you can do is, so you make a line until you surpass your target total depth, and then what you can do is you can like move this one up appropriately. So like if you do this, then now you have like a smaller total depth. And I think that if you do that, you should be able to construct like anything. So like for this, d equals 1. For this, d equals 3. For this one, d equals 6. But then if you moved this like up by 1, you would have d equals 5, and if you moved it up by 2, you would have d equals 4. Like if you imagine doing this one instead. So that allows you to get anything you want if you don't have a restriction for how many vertices you use. But now we do have that restriction, which I guess complicates things. Yeah. Let's check the standings. Wow, this person did the whole contest starting 10 minutes in. Very nice. Neil's like almost done. Oh, actually, I'm not doing too bad. I thought I had kind of a slow start. I did, right? My B was really slow. Cool. All right. Anyway, back to the actual contest. Oh, actually, it looks like there are a lot of solves on F. Let's see. Yeah, there are more solve. Wow, there are a lot more solves than F. Maybe I'll switch gears. Oh, cool. I love coordinate axes. Right. All right. So for any pair of points, they either their minimum distance is either their starting distance. Like if you have like some points, like the minimum distance between them, if they like move, is either their starting distance if they go further apart like this, or it's 0 if they don't go further apart. So I think we basically just need to count over all points that diverge from each other what their starting distance is. So I think we can do that. I'm trying to figure out how. Like, so for a given point, you have its velocity, and then anything to the left with smaller velocity will diverge, and anything to the right with larger velocity will diverge. So I guess let's start by adding up all this stuff on the left. So I think what you can do is, if you like inserted the points into a data structure in order of velocity, then you can use like a Fenwick tree. All right, let's try coding this up. Maybe I can get a little intuition about it while I code. I think I'll just use pairs. Oh, I guess, okay. Not like that. Oh, and you also need to consider all the pairs that have the same velocity, but we'll do that later. Okay, so identity associate operation. Okay, cool. So oh, okay. I guess I still want the coordinates. Oh no, okay. This is actually quite annoying. So I want the coordinates in order to see what's on my left. I guess I can compress the velocities and then do the same thing with velocities. So over all the stuff that I've put in on my left, what's the stuff with smaller velocity? I guess that seems cleaner. Yeah. Nice, got a better hydrate. Cool, this didn't compile. Let's see why. What? Oh, I'll just comment this out, actually. Why did I try to comment it like that? Is that a shirt that has that emote on it, or is it just a red shirt? Why are these already sorted by velocity? Is that a coincidence? That's super annoying for like my testing purposes. Whatever, it looks right. Now, why does this not compile, actually? Well, I guess I can just sort them the default way anyway, so like, that's fine. That does sound cool. Alright, so... Okay, so now I'm putting things in from left to right, x coordinate. So we want to add the current x coordinate to that velocity. Then we want to add everything with a lower velocity than us. Ugh, then we also have to count the number of things with a lower velocity than us too. Okay, and then we want to do the same thing in reverse. Oh no, I guess we don't. I think everything will already be added. Yeah, because... well, that's cool, I guess. Okay, so let's try hand tracing this example. Okay. So these all diverge, so the answer should be the distance between 1 and 2 plus the distance between 2. Wait, what? Oh no, these don't all diverge. 3 doesn't. 3 diverges from 1, so this is 2 plus 3. Okay. So that seems right. Oh, I need to add a count. Okay, so this should have runtime error. Oh, what? Okay, cool. And now this should actually work. Oh no. Oh, this should be the size of velocity, actually. Cool. Nice. Meal's done. Alright, 28, not bad. Alright, now let's tackle this E. Alright. Looking at chat. I'm doing a virtual contest, which is why I'm not looking at chat much. I'm gonna explain the problems after the contest, and I'm explaining them a little bit as I go, but I guess I could be explaining them more. Yeah, a lot of people suggesting merch. Definitely happy to have merch if people actually want it. Maybe if someone can come up with a cool design or help me out. And by the way, if you're watching, definitely follow if you'd like to and subscribe if you can. And this video, as with my other videos, will be up on my YouTube later. Alright, now back to this hardest problem, I guess. Okay. So my intuition is for a problem like this, there's probably like some, I don't know, kind of like reasonable construction that's like, right, like this one that I described, it's a very systematic construction that can just get you any number. I guess here the answer is no for a case, but I guess we can try to figure out why that is. Is that testing compiling script available? Not really. It's kind of inside Socket's GitHub, but I've made some of my own kind of personal changes to it. I think for testing and compiling, you can kind of just do whatever you're comfortable with. It's basically like a for loop that like runs all the tests from files and like compares the output with like the intended output. Like I just have all these like sample1.in, sample1.out, and it just checks if they're equal. All right. All right, so back to this. So the minimum answer for n vertices is if we do something like this, right? Just put everything as high as possible. So it's 0, 1, 1, 2, 2, 2. It's like for this example where we have 6 vertices, you get 8. And then like 7 vertices, you would get 10. So I guess we can find like the minimum value possible by making like this, I think it's called like a complete binary tree, or maybe a full binary tree. I never remember the difference, but you know, basically it has this kind of shape like a heap. Someone says yo in the chat. Oh yeah, the competitive companion part is separate. All right, let's see. So the question is, once we found this thing that gives you the minimum, right, and then whatever gives you the maximum would be like this. So now we need to figure out, can we get everything between them? And I think the answer is probably yes. That's my intuition. Yeah. So I'm kind of thinking like, if I want to increase this by 1, can I just move one of the things down a level? And it kind of seems like you can. So whenever you have 2 children, okay. All right, so let's try some simple examples. So this gives you 0 plus 1 plus 1 plus 2 plus 2, which is 6. And now if I whoops. Let's do green. So now if I remove this and I put it here, I get 7. And then I guess the maximum answer would be 15. So we want to see if we can get everything up to 15, which is like a lot. Well, we can also, when we add a new node, maybe there's an idea here. When we add a new node, we can either add it as the next item in like going across the rows, or we can add some number of nodes to the top like this, which would increase the answer by a lot. So maybe there's some kind of way that we can combine those to get what we want. No, I guess. I guess I should try to understand what the actual lower bound is. So it's something like so I guess you have 0 and then you add 1, 2, then you have 4, 6, 8, 10. And then the next one will add 3. This is a little bit of a weird kind of pattern. Maybe there's a solution where you start with like this long vertical chain and then you try to reduce the answer. Oh, Aaron, thanks for the follow. So let's try this example that they had, 5, 7. So if you just do 5 like this, you end up doing, you get 10. And then if you move this one, 1, 2, 3, up, you end up subtracting 3. Yeah, I might do a video sometime about setting up my programming environment, but it's very kind of like up to personal preference, right? Like, it depends a lot from person to person. So I don't know if it's that helpful to try to copy my setup exactly. Okay. So I guess we can kind of have like a queue of, you want to move the lowest vertex to the highest position at each time until you pass the answer, and then you want to move it like less than that. Yeah, I think that actually would work. And then you kind of have to reconstruct the actual tree. But let's try to code this up. Oh, is that Gary Kasparov in the chat? I've seen your ads for Masterclass on Chess YouTube. Right, and the maximum answer is like 500 squared or so, so I can use ints everywhere. Right, okay. So now so the next available score is 1, and there's 1 of them available. So it's like at depth 1, we have 1 available thing. Okay, yeah, this sounds right. Yeah, that's not what I wanted. I want something like this. I literally tried using const expert here, and it's saying there's a compile error of some kind. So I guess I need to Google this. um, okay. Okay, awesome. So this seems like this works. How do I add everything from one? What is this? Oh, that doesn't make any sense. Okay, cool. Awesome. What is the best way to actually fix this? How often do I do fast, slow solutions? Yeah, pretty rarely, but it's sometimes good. It's good for constructive problems where you're like, I can't tell if this is right or not. Um, yeah, I think fast, slow. Yeah, I mean, a lot of the time, if you're doing a problem that you kind of know how to do, it's like, wait a second. Oh, this is not. It's so annoying. What? What is this printed? Oh, it's printing some new lines. Guess this is what I want. Okay. So, 0, 1, 1, 2, 3. Okay, so that's correct. But then this doesn't appear to be adding anything. So why isn't it? Oh, it is. It's adding 1. Okay, so that's fine. So the next thing should spit out the 1. Oh. Oh, okay. Right, anything can have 2 parents. Can anything have 2 parents? Hmm. This would be 1. This would be 2, 3, 4, 5. And then for this example, we would have okay, I think this looks right. I think I'll just submit it. See what happens. Alright, it's taking a while on test 2. Is that gonna TLE? Wrong answer. Oh wait, this is definitely wrong. Ugh. This thing is just completely wrong. This will infinite loop. So let's make an example that's the same as the first sample, but you actually want one more. Yeah, alright, so we have an infinite loop here. So now what we want to do is else diff equals score minus target int level equals line dot back minus diff other dot pushback level score equals, I guess I'll say minus equals diff to be consistent. I mean, it's like, I can just say break here, honestly. I guess I'll do this for consistency. One, two, two, three, 5. So this would be, wait, what? Oh, right. Just finished my practice session and found my stream. Oh, that's awesome. What were you practicing? And I guess how were you practicing? Just curious. Alright, so now we have 1, and then 2, and then 3. Okay, yeah, cool. So now this should be right. Let's just check this TLE. Okay, cool. I think this break is unnecessary, but you know. Oh no. Wrong answer. Oh, a slow solution for this problem would be like kind of annoying. It would be like yeah, I think the analog of fast slow for a constructive problem is you write a verifier. So you write something that takes your answer as input, or sorry, it takes your output as input and then verifies that like it actually works. So what you would do like for this problem, well, you probably get the idea, but for just in case, and for all the other viewers, the idea here is like if I wanted to test this locally, what I would do is I would add some code with asserts at the end that checked that the answer that I'm printing out is actually a valid binary tree with n vertices and a total depth of d. And then I could just run this on like random inputs. Of course, this wouldn't catch the case where I print no and the answer is supposed to be yes. Yeah, exactly. So for that, I don't know, like if I'm like fairly confident in like the bound or whatever, then I can just like trust that part. Like I can at least verify. I think the yes case is definitely the harder case. But who knows? Maybe I have an error in the no case. Also, I see Crow in the chat, but I'm pretty sure Crow is also virtualing this contest, so I'm not really sure what the deal is there. So, alright. Well, don't give up. I guess don't do whatever problem you watched me do just now, but go back and do the next unsolved problem. Yeah, I'm not really sure how to approach this. Alright, so let's say we have 3 vertices, and we want to make a total depth of 3. What? Why isn't this printing the answer? Oh, maybe it's not flushing. Yeah, I'm definitely a little confused as to what I am printing here. Oh, I guess 1, 2 is the output. And that seems right. 3, 2. 1, 2 is also the output when I said 3, 4. That's definitely wrong. Sorry, let me rerun this with a smaller test case. Okay, cool. So the problem here is if wait, what? But oh, I see. Okay, yeah. So if score is less than target, PS no return. Okay. Alright, I'll try submitting this now. Alright, nice. We got accepted. Cool. So I'll go over the problems now, I guess. Or maybe I should wait a little bit? I'm not really sure. Oh, cool. It's the daily PogChamp. Yeah, I like that they're doing that. It's kind of cool. All right, I guess we can look at the standings. All right, cool. So, got wrecked geothermal. If you're watching, sorry. Wow, yeah, a lot of people did this really fast. The +2 means that I had 2 wrong submissions. So on this one, I had 2 wrong submissions and then accepted. And that actually impacts your penalty in some way. Like your penalty is like the sum of these times, but then each wrong submission adds like 5 minutes or 10 minutes or 20 minutes or something like that. It's specified in like the contest announcement, but I never remember what the exact penalty is. What about -1? These blue -1s are when you have like a wrong submission or you get hacked, but you haven't correctly solved it yet. So like this thing for me said -2 before I solved it, after I had 2 wrong submissions, and then it changed to +2 once I solved it. Have you ever uphacked anyone? Yes, I have. But not that much. I don't do it that often, but I think once I figured out how to do the like, so Java sort is like n squared if you put in a adversarial case, and I think once I just like downloaded a generator for that and like used it to like uphack some people. And then there was this one contest where I uphacked actually one of my friends, so that was pretty funny. Let me see if I can find it. I think it was even a rated contest for him, so get wrecked. Maybe it wasn't rated. Let me see. That's right. Arrays.sort is n squared worst case. So the way that I sort things in Java is I randomly shuffle the array first, and then I sort it. So the chance of it degrading to n squared is negligible. And then another way to do it is to use collections.sort, or you can even use arrays.sort on an array of objects. So you could replace like all your ints with like integer objects and then sort that array. But that's slower. Doing the random shuffle is definitely faster. And it's also more convenient because then you can keep your array as an array of like int primitives, which is like what you probably would want. All right, let's see if I scroll all the way through this, if I can find a hacked anywhere. Wait, was this one? No, that was someone else. That's why I subscribed. Thanks. Oh wait, I've already gone back like 40 years, so clearly this isn't gonna work. I wonder if there's a way to see all my successful hacks. That would be really cool. Nice. Yeah, I'll have to scrub that from the YouTube video. I guess I could go through all the contests. It's kind of annoying. Nice. Yeah, okay. I guess maybe I should go over the problems. This seems like a good thing to do now. I'll post on Discord. I don't need to, I guess, wait until the VC is over to discuss the problems. Okay, cool. So let's get started on that. So okay, so for A, basically the idea here is the answer is always 0, 1, or 2. So if A equals B already, then it's 0 because you don't have to do anything. And if A is less than B, then it's either 1 or 2. And the reason for this is if B is larger, well, we know B is larger, but if the difference is odd, then we can just add B minus A to A directly, so we do it in one step. B minus A odd. And then the reason that it's 2 otherwise is because we can always just, if the difference between A minus B is even, or sorry, if the difference B minus A is even, we can just, well, I guess we can just add 1 first, and then we'll have the same situation, but now it's odd. So we can do +1 and then go to this case. And then if A is greater than B, then it's 1 if B minus A is even, because you can just do it in a single step. And then it's 2 otherwise. And the reason that it's 2 otherwise is you can just do +1, and then of course A will still be greater than B, and then that takes you to this case. So that's kind of like it's like a complete proof via casework, and I'll show the code. So I mean, the code is basically just this decision tree that I've drawn out on paper, or not on paper, but it's just a bunch of if statements. There might be some clever way to like compress these if statements or something, but I think this is like perfectly readable, so it's like completely fine. All right, so for B, I'm definitely interested in if I missed a cleaner way to implement B. So, but the idea is if you have some array, let's say like this is your array, and you have a bunch of allowed swaps, like let's say these are your allowed swaps, it basically means that like this segment of the array you can do anything you want, and this segment of the array you can do anything you want, but then stuff can't cross over between them. So what you want to do is you just want to sort this segment, and you want to sort this segment, and so on for all the segments. And that's like the best you can possibly do. And then you can just check if the resulting array is sorted. There's probably like some clever way to do this via like checking for like an inversion that crosses one of these boundaries. Yeah, I guess you could probably actually do exactly that, and that would be a bit cleaner, perhaps. But I just implemented it this kind of direct sorting way. So I'll display my code. So basically what we're doing here is we're taking all these consecutive blocks and putting them into these like ranges. And then we're sorting each range here. And then we're just checking if the final array is sorted. So that's kind of like the clear implementation. It's a little bit annoying to like type all this code out though, especially for like a division 3B. Cool, so Shimu19 says, I think I looked at each element in B starting from smallest to biggest and made sure I can move it to its final position. Why did you start from smallest to biggest? Oh, I guess because you know what the position is then. And then how did you check if you can move it? Like, I guess like, do you mind linking your submission? I can open it and just look at it. It's not easy for me to find because I'm logged in and I'm doing a virtual, so I can't read it. But if you send me a link, I'll open it in incognito. But yeah, I think maybe the most straightforward way to do this that comes to mind to me now is we want to look for an inversion, which is something where you have I less than j and ai greater than aj. It's basically just something that's out of order. And I think if you have one of those that crosses one of these borders, then you know that the answer is no. So, but yeah, let me open this submission and look at it. I'll zoom in a bit. Okay, so solve 2 is like solving the full problem. Then I guess you're looking at where everything should go. Wait, what? Oh, did you like actually just sort the whole array? Oh, so this is like you bubble sorted the whole array or something like that. and then just checked that all the moves were valid later. Oh, that's pretty cool. I guess that's nice. Of course, you are sorting the whole array still. But that's like a nice simple one where you don't have to deal with like all the you don't have to deal with all the like figuring out what ranges are valid. You just kind of find all the moves. I thought about doing that, but then I was like, I don't want to implement sorting myself. But I guess I implemented a bunch of other stuff myself instead, and like bubble sort is fairly simple. So that would have been nice. Cool. And then here we have okay, so this is kind of the same. Nice. I see you're a C++ purist. I think if you stop typing std, you might gain like 10 rating points, but that's just me. Size t, very nice. Okay, so what this is doing is wait, what is this doing? Oh, okay. So does this look for... Is this kind of doing the thing that I described where you look for an inversion or no? No, I guess this is actually bubble sorting as well, but just checking the moves at the same time. Yeah, by the way, this isn't my code. In case NorthFan just joined. But it is 20 pixels' code. So, okay, very cool. Oh, look, it's const expr. So, wait, what? Const expr, oh, wow, I do not know what const expr does. Okay, cool. So I think this is the same solution as this. Like, I think you're both bubble sorting, and then one of you is just checking all of the moves at the end, and then one of you is checking them as you go. Is that right? Okay, cool. So I guess let's go over C. I'm not going to bother coding the other solution to B just because I think it's probably, like, not so exciting. Cool. Yeah, so C was nice, and someone in the chat, I think, said that they liked C near the beginning of the stream when I first got to it. So, cool. All right, so for C, basically, they had an example here that I think makes it kind of clear. You have like then Codeforces, then Cod, then then like, and so on, right? And you want to count the number of each thing. So the way that I did that is for each letter, I just looked at how many, wow, that's very messy. But basically for each letter, I looked at how many times it appears. Like in the stuff that I've written out here, the C appears 5 times, the O appears 4 times, the D only appears twice, and so on. And the way that I did that efficiently is the number of times a given index appears is equal to the number of lengths that are greater than it. So like index number 2, this D, appears twice because this length is like 10 and this length is 3. This is 2, 2, and then 1. So you basically want to count how many of these lengths are greater than your current index, and that gives you how much this one contributes to the answer, or contributes to the answer. Cool. So let's look at the code for that. So the way that I did that, which I think was fairly clean, is I looped through all these lengths in reverse order while I went from right to left with these indices. So each time I get to the next index, I increment the number of lengths that is greater than it by however many things are actually greater than it in the array. And I just do pop back, so I don't have to keep track of an index. I can just use the array kind of like as a queue, basically, where the front of the queue is the back of the array. Cool. Yeah, so that's basically that. And then here I used longs, which I think is necessary because if you had like the whole array like many times, you would end up having like the length of the array times the number of tries as like how much stuff you added to one of these. So you do need to use longs here so you don't overflow. But for count, you're all good. There's no overflow risk. Cool. So let's go over D. Maybe I should use my tablet instead of my mouse to write. Okay. So for D, you have A, B, and C. And you want to transform them into X, Y, and Z such that X is less than or equal to Y is less than or equal to Z. And X divides Y, and Y, you can even just write it like this, because divisibility is like transitive. So what I did for this is if you fix the value of Y, then you can easily find the values of X and the values of Z that you need to use. The reason for that is, let's say Y equals 10 and C equals 37. Then you just need to consider the options of changing C to 30 or changing C to 40, since those are like the nearest multiples in 10. And then for A, you need to consider that you could change A to 1, 2, 5, or 10. That's just all the divisors of Y. So you can just loop over all possible values of Y, and you can upper bound this by like 2 times 10 to the 4th or something like that. I didn't think super hard about a perfect bound, just as long as I had a good enough bound. And the reason that you can bound this is because you can always just change all the numbers into the same number. And so that bounds your answer at 2 times 10 to the 4th, because you can just change A into B and change C into B, and then you would be done. And so if you do that, you try all your values of Y. So there's 2 times 10 to the 4th values of Y. And then for each one, you want to factor it. So that would be times approximately this, because you can factor in square root time. And then you have 100 test cases. So this ends up running in like around 1e8 operations, give or take a bit, which is good enough. Cool. Shiwu19 says I made it as high as possible while running within the 2-second limit. So did your code have like an if statement that was like, or like a while elapsed time is like less than 1.9 or something like that? That's a pretty cool thing to build in sometimes if you're trying to squeeze like a randomized solution. Like if you have a randomized algorithm. Oh, I see. Hand calculated. I'm guessing if you hand calculated the number, you ended up with around this number, assuming that your solution was similar to mine. You can also optimize this a bit by getting rid of this square root factor. If you pre-compute a sieve to factor stuff, you can factor it a lot faster. Because the number of factors you have is way less than the square root of your number. But this was good enough for passing this one. So I'll pull up the code. And my code for this was a little messy, but I think we got there in the end with an okay solution. So I used a bunch of pairs here so that I didn't have to have a lot of if statements, like if this new cost is less than the old cost, then replace the cost and replace the value. Instead, I did a pair that was like cost, comma, value, so that when you do min of two of these, it picks whichever one has the lower cost, and then it keeps the value from that one. So I think that's kind of a cool trick for problems like this. It probably costs a little bit of constant factor runtime, but I'm not really sure. But yeah, so you basically have some casework. You have y going through all these values, and then you have to make sure of some extra casework, like c does have to be greater than y. So you can't make c into 0, even though 0 would be divisible by y or b. So you have a little bit of extra casework for stuff like that. Yeah, but that's basically it. You want to go to like the next multiple of y, or the previous multiple of y, or the next multiple of y, and then for a you want to go to some divisor of y, and if you do this I or y over I, that gives you all the pairs of divisors. You can go through all the divisors in square root time, because for every divisor I, y over I is going to be on the other side of the square root of y. I see. Cool. So someone did it in terms of a instead of b. Was that harder? Because this seems like it's easier to think about, but maybe I'm missing something. The thing that's nice about picking the middle number, when you have problems like this where you have to kind of find an ordered triple of something, it's a really good trick. It's pretty common actually that you want to fix the middle number, because then the left number and the right number only depend on the middle number. Whereas if you fix the first number, then you kind of have like, you still have to pick two more numbers that depend on each other, which could be complicated. And then here I use the same kind of pair trick just for the answer, where I had a pair. When I resolved it while watching the stream, I did it in terms of b like you. That's awesome. Yeah, so I guess my stream is really causing my followers to think like me, which is, great for me, obviously. Wait, so this code actually looks super simple. That you linked. So maybe doing in terms of b was worse? I don't know. Let's see. So this is doing it in terms of a, right? So we have, wait, where is max a? Oh, it's up here. Obviously this is just a personal preference, but if I have like constants like this that are specific to the problem, I like to put them like below my template, because otherwise it's kind of hard to keep track of. But obviously whatever your personal style is whatever works best for you. Okay, so let's see. So you go through all the values of a, then you go through all the values of b. Wait, what? That runs in time? And then you go through all the... Wait, I'm super confused. Okay, so you go through all the pairs a comma b, actually. It seems, if I understood this correctly. Oh, okay, this is actually very nice. So b actually, this is much faster because you only go through the multiples of a. I didn't notice that. And then for c, you just have to pick... Oh, this is really cool. I think this is like less casework than the way that I did it. I'm not sure how to think about the runtime. I guess... Oh, actually, this is quite nice, because if you look at what these two loops go over, I think in the end what you do is you end up going over all the like if you interchange these loops and you magically change this loop to do the same thing that the current behavior is doing, then I think what you would do is you would have this loop where you fix b, and then a iterates over exactly the divisors of b. So then you don't have to do the square root thing. And then... Oh, and then this k just goes over... This is a for loop over like the two possible candidates for c, I guess. Cool. What is let? Oh. What is this? This is a lot faster than my. Oh wait, this is. Now I'm actually a bit confused. Like, why isn't this a lot faster than mine? Hmm. Oh, maybe your max A is much larger. I mean, it's twice as high, I guess. I don't know. Anyway, so it seems like these are pretty close to equivalent. Um, okay, awesome. So that's D. I'm a Rust fan. Yeah, so are you just changing like, because I saw you also use I64 and stuff. Actually, one of my friends recently started doing competitive programming and is doing it in Rust. And my understanding is that Rust is actually somewhat good for competitive programming from what he's been doing because, like, it's pretty efficient. But I'm not sure. I've tried to read his code and it's like very hard for me to read because I'm not familiar with like all the Rust features and idioms. um, but but yeah. All right, let's go over E. So the idea that I had for E is you start by getting the biggest possible score you can, and then you want to decrease it in as big steps as possible. So the biggest step would be you would like take like the bottom vertex and then you would put it at the highest position. And then you would kind of repeat that over and over. The highest available position. And then at some point you reach a point where it won't actually move higher. Like you could move this here, but like that doesn't do anything. So that kind of takes you from like the highest possible value of the sum of the depths down to the lowest possible value of the sum of the depths. And it does it in these like well-defined steps that kind of keep your tree having the same general structure, where the general structure your tree has is that it's like a nice compact tree up here with like a bunch of stuff coming off like this. So then you just, you fill out this top and then you have this long chain. And what's cool about this is then when you have a step that crosses over the correct answer, you can always just make that step smaller because you know that if there's a spot available here, there's also a spot available down here and at every point in between. So that's kind of the intuition behind my solution. And it's also nice because this solution takes you from like the largest possible score to the smallest possible score. So you don't have to do like any additional checks for whether it's possible. Like it'll just find the solution if it's possible, and then if it doesn't find it, it's not possible. Cool. So let's look at the code, which is a bit messy. So maybe I'll clean it up as I explain it. Whoops. Let me try to resize my window. Okay, cool. So this is also kind of funny. I did this so I could debug my queue. But this actually prints it to C out regardless of what the O stream you passed in was. So this is like technically like a pretty bad overload, but it works. Anyway, I'll delete it because we're not going to need it now. Okay, so what I did here is, let me just skim through and see if I can clean this up slightly. Okay, cool. So the way that this works is we're basically implementing the solution that we described over here. So we start by making a line. So we look at and we think about everything just in terms of the depth instead of thinking about like the exact position. And then at the end, given the list of depths, we can reconstruct a valid tree. But that way we don't have to think too hard about exactly where everything connects until we really need to, which is when we print the answer. Okay, so for what we do is first we construct this line graph, which maximizes the score. And then I'm just going to have this other, which is the list of depths for like these nodes that we've already moved up, because we don't want to try moving them again. And then next here stores the next available smallest depth and how many things are available at that depth still. So at the very beginning, it's 1 because you have this spot, the second child of the root, and there's 1 spot available. And then this advance just takes up 1 available spot, so it decrements the number of available things. And then if there's nothing left, then you increase the depth by 1, and the number of available spots next to this line graph is a power of 2 minus 1. Cool. So this is just a little helper. Okay, so now if the target is actually higher than what the line graph gives you, that means it's impossible because the line graph maximizes the score. Then what we do is, as long as our score is too high, we look at the big step that we're going to take from the lowest node to the highest available spot. And if this doesn't actually help us, then we know that we've reached our minimum, so then we return no. Otherwise, we take the step if we can take it without passing our answer, or our target. So the way that we do that is we just remove the last element from the line, and then we add the next available small depth spot. And then if our jump would take us past the answer, then what we want to do is we want to jump only the appropriate amount. So we just do a little bit of simple arithmetic to figure out how much we do need to jump up. And then right after this loop will always terminate, because score minus equals score minus target, meaning score becomes target. Oh, nice. Did you just finish the VC? Or do you have a couple minutes left, actually? Yeah, this is one of my, Dush1729 is one of my Discord members who is doing the VC with us. I have a couple minutes, but I gave up on D and F. Oh, nice. Does that mean you did E? Because I think E was actually like the hardest problem, based on the standings and based on my experience with it. Okay, so then we have our... okay, cool. So anyway, we have now our list of all the depths. So now what we want to do is just put them into one list. So we combine line and other. And then we just sort it. And then here's how we reconstruct the tree. What we do is we make a list of all the available spots at each depth. We can just do a queue for each of those. And the max depth is less than n, so this is fine. So first we put in the root, and the root has 2 children. So the root can be used as a parent twice. Then for each new node that we want to add, we look at what depth its parent needs to be at, and we pick one of the parent spots that are available, and then we remove it. And now that we've added a node, our new node can serve as a parent up to 2 times, so we add it twice to our available list. And then here we just need to make sure we 1 index everything instead of 0 indexing it. Like, I was referring to the nodes starting from 0, and but they want them starting from 1, so just, do that, and then we print the answer. So that's like how I did E. I think it's pretty systematic, actually. once I finally got to that solution. And then I think this diagram kind of is a good way to think about it, but I'm curious if other people did it differently. Cool. So now we can do F. And I think F was kind of a cool one. It was like I think it was somewhat simple once you kind of go through the casework, but as we kind of discussed before, while I was solving it, you have a bunch of points, right? And what we want to do is we want to find the sum of the minimum distances. So this just means the minimum distance is the starting distance if the points diverge, and 0 otherwise. So basically what we want to do is we want to go through all pairs of points that diverge from each other and find their distance. So first, we can actually, the velocities are in this inconvenient range, but we can actually change the velocities to anything. So 2 points diverge if their difference in velocities has the same sign as their difference in position, or their velocities are the same and they're at different positions. So what this means is we can actually replace the velocities with anything we want as long as we preserve the ordering of the velocities. So what we do is, like, if your velocities are like 5, 7, -3, 0, we can actually just replace this with like 0, 1, 2, 3, and this actually has the exact same ordering properties when you want to check whether two things diverge or not. So then what you do is for any point, so let's draw our number line, and then let's draw our 2 points. So if these 2 points diverge, we only want to add their distance once. So what we can do is for each point, we can find its distance to everything to the left of it that it diverges from. Cool. Yeah, so once we do that, adding that up just gives you the answer. And we can do this a bunch of ways. The way that I did it is I added all the points one at a time, going from left to right position. And then I counted up the total sum of the distances to all the points with less velocity than, less than or equal to velocity of what I currently had here. And the thing that's actually kind of nice about doing this less than or equal to velocity is that, let's say you have 3 points that all have the same velocity, you'll actually end up counting each pair exactly once. So that actually is pretty nice casework-wise. So let's look at the code. So, well, nice, the coding phase is finished. So what we did here is we read in our points, then we compressed our velocities into like this smaller range. And the reason we did that is then we can conveniently add them to a Fenwick tree or a segment tree. And so then we sort the points by their position, and we add the points one at a time from left to right. And what we do is we keep track of the number of points to the left, and we keep track of the sum of their coordinates. And the reason that that works is because if you want to find x minus x1 plus x minus x2 plus ... that's actually like kx minus the sum of xi up to k. Right, so you can take out all the x's and then you can just have these sums. So yeah, so we have our sum and then we have our count, and then what we do is we add the current coordinate to the sum of coordinates, and then we add the current, and we add 1 to the count, and we make sure we add it at that velocity. And then here we go from 0 to v plus 1. This is not inclusive, so this is 0 to v inclusive. So that way you only count the things that you actually should be counting. and then you print your answer. So yeah. So that was that. So yeah, I don't know. Do people have any questions or thoughts or anything like that? Now that we're done explaining everything, I guess now we can also look at the solutions, or not the solutions, but we can look at the standings now that they're complete. All right, so I got 31st. I guess not bad. Curious to see what the editorial says about some of these problems. This problem has an easy constructive solution. Yeah, I guess it was kind of easy once we... Wait a second. The answer for the chain is the upper bound. Oh, you know what? I think my solution is actually O of n. Yeah, my solution is O of n, I'm pretty sure, right? Instead of n times d. So maybe I did miss some kind of... Oops. Maybe I did... Let me see. Is this O of n? Yeah, this is definitely like O of n, right? I'm just... Yeah. Okay, so maybe I missed something here where we can exploit the small constraints to do it faster. For a given n, we find the lower and upper bound. Okay, cool. And then we start from a chain. That we decrease the answer by 1 in one move. What? Just give a large n as input to check. Sure, I can actually do that. Alright, I'll do 1,000,000 and I actually don't know what the answer should be. Maybe I'll try just 4,000,000. I mean, alright, it's printing a ton of stuff, right? So that's probably not great. Why is it printing so much? Yeah, okay, that's definitely not O of n times d if it ran on 1,000,000 that quickly. Okay, cool. So yeah, and just from reading the code, it's pretty clear that it's O of n because you just have a series of loops that loop through, right, like every time you iterate through this, you decrease the number of elements in line. So this has to be O of n. And the other things are just like explicit loops through n things. Technically, I sort here, which could be like n log n, but you could even do that in O of n if you wanted to, because these two lists are separately sorted, so you can do like a, you know, a merging pass through them. Okay. I guess let's read the code. Oh, this seems like, I don't know. I kind of like my solution to this a bit better. Alright, and then... Okay, cool. So yeah, so this Fenwick tree solution is the same as the way that I did it. Cool, yeah, and they compress the velocities the same way. Actually, no, it seems like... Yeah, cool. So they compress the velocities the same way. Cool. Alright, so I guess that wraps up this stream. I'll post it on YouTube later, and feel free to join my Discord. I might do some virtual contests like this in the future, though I guess it's a little bit... Oh I don't know. It's a little weird to stream the contest while also having other people in my Discord do it, just because like then they can't watch the stream, but maybe it's cool. Then people kind of have like one option or the other, and they can always watch the stream later. And if I do a VC that I don't finish like 45 minutes early or whatever it was, I'll explain the solutions after the VC is over, which would be like nice for discussing with the other people who did it. For the other people who did it, sorry, I explained everything while you were still competing. But yeah, thanks so much everyone for joining, and I'll see you guys next time.